All right, this is the next to last section. This does have a lot of sections. 1-9, that seems like a lot, but it's okay. Absolute value. Let's do a number line. And we'll talk about absolute value. Did we talk about absolute value in geometry? I think we might have. I think we might have had a lesson on it. We didn't get into a lot of detail on it, but pretty sure we had it. So let's say that's 0. Let's say that's, 5. Let's say this is -5. So if I was going to measure something, right? If I had a ruler, everybody listening? Yeah. Okay. If I had a ruler and I was going to go over here and I said, okay, well, measure like how wide that board is or how tall that board is, what would you do? Would you go up here and say, it looks like it's about -1.3 meters. Is that what I would do? No, you wouldn't say negative, all right? Anything you measure. It doesn't matter if you measure from the top to the bottom or the bottom to the top. You would still say what? Just 1.3 meters, wouldn't you?
How would it be negative?
Okay, well, that's a good question. So, would you agree with that? So, when you measure something, when you find the distance of something, you don't really worry about if it's negative or positive. It's just always that number, right? It'd be positive, but you wouldn't think about it as negative. So what about this? How far is it from 0 to +5? Just the distance. Let's say I was measuring in meters. Let's say meters, okay? If I was measuring in meters, how long is it from 0 to +5? 5 meters, right? Would you agree? Well, how far is it from -5 to 0? It's still what? 5 meters. I don't say -5 meters, do I? It's just the length of it. So the length is just the number itself. No negatives. So that's what absolute value is. Absolute value, it's the absolute value, which means only the length from one spot to the other. All right, so I don't worry about the negative. So absolute value from -5 to 0 would still be 5, just a regular old 5. Make sense? And the absolute value from 5 to 0 would again just be a 5, a regular 5. You've done this before. I know you've done absolute value before. It's got a little symbol. Do you know what the absolute value symbol is? It's just the 2 lines, right? So if I was to write this, I'd put -5. This means the absolute value of -5, which means how far away from 0 is -5? How far? It's just 5. And then whatever the units are, okay, it's just 5, +5. What if I said, what is the absolute value of +5? How far away from 0 is that? It's still just 5 away, isn't it? Does absolute value always mean you just change the sign of it? No. Okay, only when it's what? It's negative, okay? Only when it's negative do you change the sign. I don't even try to think about it as changing the sign. I always think about it as absolute 0, or not 0, but absolute value is always positive. It's always positive, all right? Because it's the length of, it's the distance it is away from 0, all right? And that's what we have right there. Does that make sense? Yeah. Well, let's talk about graphing absolute values. So what if I graphed the absolute value of x equals 2? Well, let's think about it. What could I put in for x? What is x going to equal if the absolute value of x is equal to 2? Well, I could put a 2 in there, but I could also put a what? A -2 in there. That's right. I thought you said the absolute value has always got to be positive. Well, there's my positive, but if I took the absolute value of a negative, right? So x could be negative or +2, and x could also be what? -2. Everybody see that? So that's what we have right there. So if I was to graph this, then I'm just going to put, let's put it right here. Let's put a -2 right here. Let's put a +2 right here. And if I wanted to graph it, what would you do? You just put a dot right there at -2. and a dot right there at positive 2 if it says x is equal to. Everybody got that? Yeah, pretty simple. Do you understand why it's negative and positive? Because if I took the absolute value of a negative 2, I would get positive 2. And if I took the absolute value of a positive 2, I would also get 2. So what could my x's possibly be? They could be negative 2 or positive 2. Make sense? All right, let's keep going. Sometimes teachers don't really explain what absolute value is. They just tell you that the absolute value of something is always positive, and then they kind of move on. Have you had teachers that did that? But that's right there. That is why it's always positive. All right, let's do another one. This is a little bit more like what we're going to be doing in here. Well, a little bit more. This is more Algebra 1 stuff right here, but absolute value of x plus 5 is equal to 9. Now let's think about this. Remember how we made that x a positive and a negative? Right? We're going to do the same thing with this. So this, I'll tell you what, let's go back. Let me just rewrite this just a little bit different. So right here, if I wanted to get x by itself, I would just, well, I wrote it here, but I don't know. I'm just redoing the same thing. But if I wanted to solve for x, what would I do? I would say x is equal to, what do I do with that number right there? Make one negative and one positive. You with me on that? Okay. We're going to do the same thing right here. So if this is absolute value, I'm going to write two things. I'm going to write x plus 5 is equal to, what are we going to put first? Negative 9. See what we did with that negative 2 before? We're going to do the same kind of thing. So we take what's in the absolute value, we set it to the negative version, and then we take the thing that's in the absolute value and set it equal to what? The positive version. Isn't that basically what we just did right here? Right? I took what's inside the absolute value, I set it equal to the negative of that, then I took the x and set it equal to the positive of that. It's exactly what I did right here. Okay? But it's more than just an x inside there, right? It's an x plus 5. But I took everything inside here, I set it equal to negative 9, and then I took everything inside of there and set it equal to positive 9. But I got rid of the absolute value symbols. Does that make any sense? And now what I'm going to do is just solve for x. Pretty easy. Subtract 5 from both sides. If I subtract 5, what's this? Negative 14. So that's one of my answers. We're going to put the and because it can also equal something else. What do I do here? Subtract a 5 from both sides. 9 minus 5 is 4. So both of these answers work in the absolute value. Let's see if it really does. Let's plug it back in and see if it works. Let's put a negative 14 in for this. Negative 14 plus 5. What's negative 14 plus 5? Negative 9. What's the absolute value of negative 9? It's 9. Does it work? Does negative 14 work? Yeah, absolutely, it does. Absolute value, absolutely. Let's put a 4 in there. Put a positive 4. What's 4 plus 5? It's 9. What's the absolute value of 9? It's 9. So do both of these actually work? Yep. So this is a good method to do it, isn't it? That's a good way of doing it. And those are the only two numbers that make that thing work. And that's what you just have to understand. Now, they're going to get, obviously, the algebra is going to get a little bit more complicated, but that's the basic idea. You take what's ever in the absolute value, you set it equal to the negative of this, and then you set it equal to the positive of this. Question? Then you get it wrong because you haven't given me all the solutions. All right, so you want to solve for all the solutions. This is one solution, but if that's the only thing you write down, it's not complete. You got to give me every answer. And so you got to have both of these to be able to get the answer correct. Okay? All right, let's do example 3. All right, so we got 2, we got an absolute value, we got 3x. Now this is a little bit more complicated than what we just finished doing. So we're going to have to do a couple other things before we do what we did on that last these last two. Now, do I only have an absolute value on the left-hand side? Do I only have it? No, I don't. I got some other stuff going on, don't I? So I want to make my left side so it's only absolute value of something. Everybody hear me? So the left side, I want just the absolute values. All the stuff on the outside of the absolute values, I need to get rid of them. All right, so I'm only left with absolute value. So what am I going to get rid of so I'm only left with the absolute value? Add the 8 and then divide by 2. Exactly. So we're going to add an 8. What's that? 32. Divide by 2, which is 16. So all of this, it's still inside the absolute value, isn't it? So now I'm basically just left with what I did on the last example. So that's the key to this example right here. Get rid of all the stuff that's on the outside of the absolute value, put it on the other side, and then just get yourself the absolute value by itself. Now we can do what we just learned a few minutes ago. So you got an absolute value is equal to something, so what are we going to do? We're going to go 3x minus 12 equals what first? We're going to write down two of them. What's the first one we're going to do? Negative 16. Okay? And then, what else are we going to write down? 3x minus 12 equals positive 16. So we're just writing it twice. One, we're setting it equal to a negative of that, whatever's on the right, and then the other, we set it equal to the positive version of whatever's on the right. And now we just solve for it, and it's a piece of cake, right? No big deal. So really, that's the only thing different about this, is that you make two equations instead of just one. You got it? All right, so let's do this. Add a 12. What's that? Negative 4 divided by 3. So x is negative 4/3. Let's do this one. Add a 12. What's that? 28. We'll divide that by 3. And so x is equal to 28 over 3. And that's your answer. Circle them both. You could put an and in between and just circle the whole thing, both of them, but you got to make sure you have both of these answers, negative 4/3 and 28 over 3. So that's not too hard, is it? Pretty basic. Do you remember doing this in the past? I don't know if you did or not. Can't remember if you did this stuff before this class or not. If you didn't, it's fine. Now you know, right? Let's do one more. Well, two more, actually. Remember how I checked that other one? I'm not going to do this one just because the numbers are a little bit uglier. But when you do this absolute value stuff, it is important that you check it, because sometimes it won't check, right? Sometimes one will work and the other one won't work. Sometimes neither one of them will work. Even though you did your math correctly, sometimes when you plug it back in, it's not going to work. So you got to be careful. I'll tell you right now, both of these do work, all right? But you don't know just by looking at it. You're going to have to plug it back in. And we're going to do an example where we do that. Noah? You sure? Okay. All right, let's do this one. Absolute value of 2x plus 5 is equal to negative 4. Now, I can just look at this, and you should be able to just look at that and tell me what the answer is without doing any math in your head, or any arithmetic, I should say. Why is it no solution? Because the negative 4 is at the end? Is the answer? Why? What's wrong with this being a negative? There you go. That's what I was looking for. The absolute value of something cannot equal a negative number. So I don't have to worry about, making two different equations and then solving for x on both of them. I just look at this and I'm like, this says the absolute value of this is going to equal negative 4. It doesn't matter what x is. What happens when I stick any value for x in? I got to take the absolute value, which is going to make it what? Positive. Can I have a positive number equaling negative 4? No. it can never happen. So this is no solution, just by looking at it. Everybody got that? Yeah. So that was kind of nice, kind of easy. Let's do one more. Example 5. That was example 4. I didn't write that down, but this is example 5. So this one says, again, to solve, and it's 2x plus 9 inside the absolute value is equal to 3 minus 8x. All right, this is a little trickier. Same concept, same idea as what we've done before, but the right side's a little different. The right side's not just a number. It's not just a positive whole number or something like that. But we're still going to do it the same exact way. So what do you think we're going to do first? Let's split them up. So 2x plus 9, get rid of the absolute value. What are we going to do first? Make that what? What did we do earlier? Made one negative, made it positive, right? So let's make it negative. Do you agree? So we've been doing. We've done it like 3 times already, right? So we're going to make the one positive, and we're going to take that thing inside the absolute value, get rid of the absolute value symbols, and just keep this what it was. It doesn't mean you make everything positive. Since that's a minus 8, doesn't mean you make it. You just keep it the same. All right? We'll just say it that way. All right? So we don't mess with that. We just write it just the way it was. But this one, you're going to make it negative. Now let's do some math. So I've got 2x plus 9 equals negative 3 plus 8x, correct? Let's see. Let's move the x over here. Is that all right? Minus 2x. Uh-oh.
No, it's not okay.
Oh, man. Why did it do that? It's still recording. Let me see if anybody's watching this on YouTube. My screen just went blank, so I'm going to try to connect it again. But I can see it on my computer, and you probably see it. There it goes. Let's hope it works. All right. All right, now we're back to where we're supposed to be. I don't know why that happened. I didn't touch anything. It just went away. All right, so let's see. We subtracted 2x. What are we going to do here? Add a 3, correct? So that's 12 equals 6x. Divide by 6, what's x? Equal to 2. All right, so that's good. I'm not going to circle it just yet. All right, why not? Because I'm going to have to do what to? What did I say we should do with every one of these? We should always check it, okay? So we'll check it, and we'll wait until we find out if it works or not before we circle it. Is that all right? Let's do this one. Same idea, but this one, 8x, I'm going to put it over here on this side, which gives us a 10x. Subtract 9 from both sides. What's that? Negative 6. Divide by 10. That's 3/5 negative, so it's negative 3/5. All right, it would be nice if I could just circle them both, be confident that that works. But we always need to check, because sometimes it works, sometimes it doesn't. And it's hard to tell whether one answer is going to work or it's not going to work. All right, so we got to check. So let's put the 2 in for this. All right, so we are going to check. Let's put a 2. So 2 times 2 is 4. 4 plus 9 is 13, correct? Put the 2 in for this. So this would be what? 3 minus 16. What's 3 minus 16? That's negative 13. Does 13 equal negative 13? No. So can I put a 2 in for this? Is this one of my solutions? No, it's not. Now you see why I didn't circle it. Now, how would I have known that before? I wouldn't have. So what do you have to do? You got to check. Everybody with me? When's this class over? 25? Okay, 5 minutes. Well, we got to try the other one. Now, the other one's a little uglier, but we still got to try it, okay? So let's put it in for this. So we're going to write it down. So it's 2 times negative 3/5 plus 9. Let's see what that is. That's negative 6/5 plus 9. And might as well find a common denominator. So it would be 5. I've got a negative 6. If I make that 5, that would be 45. And that would be what? 39? Is that right? Or yeah, 39/6. Is that right? Yeah, that's right. 39 over 5. Yes? Let's try the other side. 3 minus 8x. So let's go 3. Do it right here. 3 minus 8 times x. What do we say x was? Negative 3/5. All right, so it's 3 minus, nothing cancels here, so 24/5. Make this over 5, so what's that going to be? 9. Am I doing that right? No, times 5 is 15. What am I doing? So it's, oh, did I mess, where did I, let's do this again. I lost track. I think we did this right? 3 minus 8x, let me check. Yeah. Yeah, so that's, is it negative? Yeah. Am I doing something wrong? 3 minus. Oh, minus a negative. My bad. That's where I screwed up. All right, I got it now. Minus a negative is going to be plus, isn't it? So if this is over 5, that would be 15 over 5. That's where I messed up. Minus a negative is plus, what? 24 over 5. So that is 39. So that is 39 over 5. So the left side is 39 over 5. The right side is 39 over 5. They are equal to each other. So does that check? Yes, it does. So guess what I can do? I can circle that, and that's my only answer. So this does not work. I don't get 2 answers for this. Okay, I only get the 1. Sorry about that right there, but I wasn't writing it big enough. I should have done that. Probably would have made it easier for me. And there you go. So that one checks, that one doesn't. So that's my answer, and I'm done. Now, remember that first one we did? This one right here. Remember, got these weird answers? I just told you that they both check, but if this was a homework problem or a quiz or test problem, you would need to put those back into this to see if it really does. I'd probably put it in for this one, right? Because that's the same as this, isn't it? Right? So I would put both of those in there, make sure it checks, make sure the left side is equal to 16. They both do work, all right? But I just didn't want to go through all the hassle of going through it. But you need to. On a quiz or a test, you need to go through the hassle because sometimes you get 2 answers, sometimes you get 1 answer, sometimes you don't get any answers. Sometimes neither of them work, all right? So you got to make sure. I can't hear a thing you're saying. The distance? Oh, does it ask for distance and midpoint formula? Does it really? All right, I'll write it down for you. You don't have that memorized from last year? Distance is the square root. Remember this? So it's x1 minus x2, y1 minus y2. All right, what is the x's and the y's? Well, they're 2 ordered pairs, right? So this would be x1, y1. This would be x2, y2. Oh, well, oh, is that all it is? Oh, that's super easy. Now look, watch. If I wanted to find the distance between, if this point was 5 and this point was 1, what's the distance between them? It's just 5 minus 1, right? That's the distance between them. No, it wouldn't be 6. What's the distance between here and here? It's 4. It's 4. So the distance is 5 minus 1. That's the b minus a. Okay, if this was a and this was b, it's b minus a. Now, where's the midpoint? How do I find the midpoint? What do? I add them together, and divided by 2. So the halfway in between would be 6 divided by 2 is 3. So the halfway point would be 3. Or a plus b over 2. So that's the formula they're asked. So they don't ask for this, right? I didn't think they would ask for that. But yeah, that's what that is. Homework is, I did not write it down on my thing. What is it? 3 to 22? 3 to 22. I don't know. Just look at the section. Go to section 1.8. Go to the homework. I don't have it in front of me. I usually write it down in my notes. I didn't do it this time.